This will be a step-by-step tutorial on how to create a logistic regression model in PyTorch. It's going to be simple steps, 12 of them. We are going to be taking these 12 simple steps to create a logistic regression model in Python. We are going to be importing the modules. We load up the data set. In this case, is the breast cancer data set that's available in sklearn. We are going to get the number of samples and the number of features. We are going to split the data into train and test data set using a function called the train test split in sklearn, the pre-processing library. We are going to scale our data set. We convert from NP array to PyTorch tensors. We reshape the Y tensors to column vectors. Then we set up the model class. We instantiate the logistic regression model, create the loss function and optimizer. I think you should know this one from the previous class about linear regression. Then we are going to perform the training in 100 epochs. We are going to evaluate the accuracy of the test data. Now, I've created this diagram here just to show you the difference between the logistic regression model and the linear model. So you can see here in this diagram, we have the linear model. You can see the equation to be y is equal to b0 plus b1x. So we have the linear model here having the slope and the intercept, that is the coefficient, and the bias. So this BO is the bias and B1 is the coefficient. But in the logistic model, we are actually using probabilities, which are calculated using a logistic function, which could be sigmoid or tan or a number of other ones. In this class, we are going to be using the sigmoid function for the output layer to calculate the final values. So let's take this step by step, and I'm also going to be explaining as I go. So now let's go ahead to start with the imports of the necessary modules. Again, I would like to remind you, if this is your first time visiting my channel, please consider subscribing to my channel by clicking on the subscribe button below so that you don't miss any updates, and also you kind of motivate me to keep making these lessons for you. So I'm going to import PyTorch as usual, import Torch. I'm going to also import neural network. So I'm going to import torch.nn as nn. We also need to import numpy as well, numpy as np. And we also need to import the data set we need from sklearn. So we are going to say sklearn.data from sklearn import data set. So I'm going to kind of increase this. Okay, I think that the font should be okay. Import data set. Then we're also going to import standard scalar from sklearn.preprocessing. Import standard scalar. And finally, we will need the train test split. This is a function to help split our data into training and test data sets. So I'm going to import that from sklearn. Sklearn.model selection. Import train test split. Now this will be from sklearn import dataset. Now we completed part 1, import the required modules. Now in step 2, we are going to load up the breast cancer dataset. So I'm going to say dataset is equal to dataset.load breast cancer, and this will load the breast cancer dataset. We're going to actually see the features x is equal to dataset.data and y is equal to dataset.target. So you can go ahead to actually see what is here. Actually going to run this first and then run this one. So you can see I'm going ahead to print. You can actually print it out if you want. So, but for now, I think I should just take a look at X. So you can see the dataset X is an array. I think I'll not create this clutter here. Okay, so we want to see the number of samples in our data set. So I'm going to say n samples, and also number of features, n features is equal to, you get it from the shape x.shape, and I'm going to display these values, print and samples, number of samples, and the number of features as well. So if I run this, you can see that we have 569 observations or samples or records, and we have 30 features. Okay, so now we want to split our data set into training data set and test data set. So we'll need the training data set, the X, and also the test data set, X test, and also we'll need the training data set, the features for Y, so Y train and Y test. Okay, so we have the features for train, features for test, and output for train, output for test, and it's going to be train, test, split, and we are going to provide the X and Y, the data we want to split, X, Y, and we are going to provide the split percentage or proportion. In this case, we want to use 20% for test and 80% for training. So this is going to be 0.2. Random states, and just use 1, 2, 3, 4. I think this should be fine. And I'm going to simply run. So this is not test, but it's going to be test size. So the next thing we want to do is to scale our data set. To scale our data set is necessary for analysis, for performing logistic regression. So we want to scale it so that this data set is going to have 0 mean and a standard and a variance of 1. So I'm going to create a standard scalar object, and I'm going to simply say xtrain is equal to sc.fit and provide sc.fit transform and provide the data you want to scale. So it's going to be xtrain, and in case of the test as well, we are going to simply transform. Okay, so we scale our data set, and I'm going to run. Now the data set we have from the data set from sklearn, they are in NumPy array when we import this data set using NumPy. So we are going to be converting them to tensors because we are going to be working with tensors. So this data set in NumPy, as NumPy array, we are going to convert to tensors. So I'm going to first say xtrain is equal to torch dot from NumPy, and it's going to be xtrain dot as type mp dot. So we are saying torch that from NumPy, and also we are converting to float because NumPy gives us data type of double. So we are converting to float 32, and we are going to do the same for every other data set. So we are going to do it for xtrain, for ytrain. We're also going xtrain, xtest, ytrain, ytest. So let's say xtrain here, xtest, and here we need to say ytrain and ytest, and we are going to do the same here. So this is going to be test, and this is going to be ytrain. Here we are going to be having ytest. So hopefully I'm not missing out anything. Okay, so I'm going ahead to run. Okay, so now the next thing we want to do is to reshape the Y tensors to column vectors. For you to perform tensor operation, you need to actually reshape the output data as column vectors. So to do that, we have a function called view that helps us take the shape we want, the target shape we want. So first we want to reshape the output for the training data set. So it's going to be ytrain.view, and now we are going to provide the shape. In this case, it's going to be just column 0 and 1 item per column. So it's going to transform it into a column vector. And we are going to do the same thing for our test data set, ytest. Make sure I have everything correct. Okay, so we reshape our tensors to column vectors. So just run. Okay, so this is going to be y test. Okay, perfect. So now we need to set up a logistic regression class. And we are going to write this class, and then we are going to override the forward methods and also write the init methods. So let's go ahead to create this class. Is equal to, this class is going to inherit from nn.module. Now we first create the init method. Okay, so in the init method we have self. And for us to initialize this model, we also need to provide the number of features. So in this case, I'm just going to use this parameter and impute features. Now for the init, we are going to call the super class init. So it's going to be super get the self, and we are going to call .init on the super class. So we are going to create our input layer. It's going to be a linear layer. So self.linear is equal to nn.linear. So it's going to be our input layer. And we are providing the number of features that is going to go into this input layer. And input features, and the number of output, in this case 1, because this is only one class. So it's only just one output variable, which will be either a 0 or a 1. Okay, the next thing we want to do, we want to define what happens in the forward function. So I'm going to override the forward function. So I'm going to say forward, and also it gets the self, and it also gets the data as well. In this case is x. Now for the forward, we are going to calculate the outputs. So to calculate the output, we are going to call the sigmoid function to actually transform the input to either a 1 or a 0. So y predicted is going to be torch.sigmoid self.linear, and then we provide the x, and then we are going to return the results, what was predicted. So in the forward part, we are going to perform the calculation and return the results of the calculation. So this is basically what happens, what our model does. Our model simply makes the prediction and returns the result. Okay, so this is our model, quite a simple one compared to the previous one. So what we are going to do now is we are going to instantiate our model. So first, let me just run it just to make sure we don't have any errors. And then we are going to instantiate a new model. So it's going to be logistic regression, and we are going to provide it with n features. The number of features we have here, we say it will be 30, right? So n features is 30. We already calculated this n features, so it's going to be 30. So n features is 30. I'm going to go ahead to run just to make sure we don't have errors. As usual, we are going to create our loss function and our optimizer. So the loss function, we are going to be using an inbuilt loss function, which is binary cross entropy BCE loss, and we are going to also create the optimizer. In the case of the optimizer, we are going to use the same optimizer we used for linear regression, and that is going to be stochastic gradient descent. So it's going to be tosh.optim.sdg, and we are going to provide what we need to optimize. Is the model parameters, and we're also going to provide a learning rate. LR is equal to learning rate, and I'm going to declare a learning rate variable here. Learning rate is going to be 0.01. Of course, you can increase or decrease, but As best practice, I'm always using 0.01. So actually, I'm going to put this right here. Yes. Okay, so we've created our optimizer and our loss function SGD. Okay. All right, so we want to now perform the training, and I'm going to perform this training in 100 epochs. An epoch is a forward and a backward pass gives you one epoch. So I'm going to perform it 100 times. So I'm going to create epoch. It's going to be 100 epochs, and I'm going to, for each of the epoch, epoch in range epochs. So what I'm going to do here, for each epoch, we are going to calculate do the forward pass and make predictions. So the forward pass, we are going to make the prediction. So it's going to be y predicted. It's going to be, we use our model and give it the training data set. And we also calculate the loss as well. Loss is equal to the loss function. We have a loss function, and we are going to give it the predicted values, and we also give it the actual training values. Okay, so this is the forward pass, and we do a backward pass, right? So we do a backward pass. In the backward pass, we simply calculate the gradients. So it's going to be loss, the backwards. So this all you need to do, and PyTorch is going to do the whole calculation for you. And we want to update the weights after the backward pass. We want to, during the backward pass, we also update the weight, but we do it in a different step. So we perform the weight updates, and to do this, we simply call optimizer.step. And finally, before we go to the next iteration, we want to empty the gradients so that we don't have the gradient accumulating from the previous epoch. So I'm going to say optimizer. So I'm going to put the comment empty the gradients. So it's going to be optimizer.zero grad. Okay, so for each epoch, I want to print out some metrics. So I want to print out the epoch and also the loss. We want to see that the loss is actually decreasing for each epoch. Print the losses. So I'm going to print if epoch plus 1 every 10 epoch I'll print. So I'm going to do mod 10 equal to 0. I'm going to print f. I'm going to print the epoch as going to be, the epoch is going to be epoch, and I'm going to print the loss as going to be loss.item, right? We calculated loss.item, and we want to display in how many decimal places? 4 decimal places, maybe, or it could even be more, maybe 5. Okay, so we perform our training here, so I think we can go ahead to run. I think this is a problem here, so we are going to put a semicolon first before the floating point, and then I'm going to run. So it tells us self is not defined. Okay, so I have a typo here. This is self. Okay, so so it's going to be self here, and it's going to be self.linear. So this is correct. Put the .sigmoid self.linear x, and I'm going to run this. Okay, looking at this line 9, this is going to be x test. Okay, so I think we had a problem. So I'm going to see. Okay, so I think we solved the problem. So I'm going to simply run this. So we have 10 different epochs, and let's see that the loss here is 0.54402, and it's going down all the way to 4.5 all the way to 2. So we have the loss is reducing. So let's now evaluate the accuracy of this model. So I'm going to evaluate the accuracy. To evaluate the accuracy, we are going to be using our test data and compare it with the predictions made in the test data compared to the actual values. So I'm going to say so I'm going to calculate the predictions for the test data. So I'm going to call it y predicted. It's going to be model, and I'm giving it the test data set, which is x test, and I'm going to calculate the outputs classes. The classes this time is equal to y. Now, since we are dealing with a logistic model, we are going to round it to actual values, because we have this value from 0 to 1 for this output of a sigmoid function. Value from 0 to 1, we are rounding. When we round, it can either now be 0 or 1. So I'm going to round. Okay, so we have our y predicted class now. We are going to now sum all the correct predictions and divide it by the total number of samples in the test data set. So accuracy is going to be the y predicted classes. We are going to sum up where the y predicted classes is equal to the y test, and we are going to sum up all the correct predictions. We are going to divide by the test size. But we are going to convert to floats here so that we'll be able to perform a float division and get the accuracy as a float. Okay, so I'm going to print out the accuracy, and we are going to display it as 2 decimal place maybe, or 4 decimal place. Okay, so let's see what accuracy we have here. So I'm going to run y predicted classes, y predicted class, right? So it's going to be y predicted class, run. So we have a good accuracy of 0.9035. This is impressive. It's a very good accuracy. So our model performed perfectly well. So I think we've done a good job. But if you want to play around with this, you can change a few things. For instance, you can increase the number of epochs to maybe 500, and also adjust the learning rate. And also, in case of your data set, you can also adjust maybe make this 30% for the test size. And then you can also adjust the random state just to get used to how these parameters affect the accuracy. I would like to stop here. Please remember to subscribe to my channel so that you motivate me to keep making these lessons. And also, if you have challenges, leave me a comment in the comment box below. You can also like this video if it has been informative for you. So we see you in the next class.